Yo, what's good? We got another video on some questions, and today we're going to be speedrunning solubility. So yeah, let's just get on with it. Yesterday was acids and bases, so today we're going to just be doing solubility. Yeah, bro, midterm tomorrow. How are we feeling? Not too good, bro. Not too good. We'll just see how this goes. Hopefully, this can go like much more faster compared to the last one, but I think this is like way more easier. So let's just start. SR3 PO4 2. This is the solid. I feel like because I already talked about all this before, it'll just come back to me, and I already did like a practice midterm with all these questions, so this is just kind of like extra review. And I'm also losing my voice, so that kind of helps as well. So we put excess here, right? Minus x, excess, plus x, 2x. 0, 0, wait, this should be plus 3x, 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 2x, and we know that KSP is that. Okay, so now we just got to put products over reactants, but it's excess, so, and it's a solid, so we don't need to put this in. Okay, so 3x, 2x, 3 times 3 times 3 is what? 3 times 3 is 9. Bro, wait, I'll just put this in my calculator. I'm just going to get x to 5 over 1.0 times 10 to the negative 31 over 27 times 4. Should get a value of... Yo. I should like try putting these in my calculator properly so I could like have like the muscle memory for tomorrow. .5 times 10 to the 1, 2, 3, 4, 5, 6, 7, negative 7. So that's the answer. Wow, that was quick. Okay, number 2. Let's get. Whoa, my water bottle's gonna fall. One sec. Bro, my bad. Okay, let's lock in, bro. Distractions, bro. Distractions as in emails, bro. Yo, tomorrow I have to sign up for some volunteering thing, and I actually need to make sure I get this. Otherwise, I might be cooked, bro. Okay. KSP for silver sulfate. Okay, so this is just talking about the different initial concentrations. Okay, this is easy. So it's Ag2SO4. Okay, I'm not really putting in the charges, but I feel like you could just figure that out, right? Maybe I should, because I'm low-key feel like I'm just leaving it behind because I don't want to figure it out. Maybe, I don't even know, excess. So we're going to start with water conditions. So it's going to be 0, 0, plus 2x, plus x, 2x, x. So this is going to be 2x squared times x equals 1.2 times 10 to the negative 5 x cubed over 0.3. I actually don't know if that's right, but I'll just plug in the original value. Bro, what is it? 3 second power squared. 1.2 e negative 5 divided by 4 should get 1.44 times 10 to the negative 2 moles. Okay, that's part A. Now part B, we'll just change this to AgNO3, so it's going to be 0.1. So how would that change our value? We'll get 2x plus 0.1. I'll just write it again. 2x 0.1 plus 2x squared x small k. So this is just going to be crossed out. Oh, we have to do 5% assumption, that's annoying. Okay, so x is going to be equal to 1.2 e negative 5 divided by 0.1 squared. Should get a value of what? 1.2 times 10 to the negative 3. Okay, that's easy. Now part C. No, bro, we're just going to fit everything in here. 5% assumption rule. Okay, I guess we'll just do that as well. So it'll be 1.2 times 10 to the negative 3 times 2 divided by, what was it, 0.1? And times 2. My bad, divided by 0.1. Multiplied by 100. We get 2.4%. Less than 5%. So it's chill. Okay, now part C, we're just going to be putting 0.2 here now. 0, so this barely changes anything. Okay, x. So then 1.2 divide 1.2 e negative 5 divided by 4 times 0.2 square root that 0.0039. Is that right? Yes, sir. 3.9 times 10 to the negative 3 moles. Check the rule. Divide this by 0.2. 100. 1.9% is less than 5%, so we're chill. Okay, boom, so there you go. You could see that this is the most soluble, this is the least, and this is the middle. I think. Yeah, it should be right. Yo, my phone's heating up. Bro, people just be yapping for no reason, bro. Big. Okay. Next question here. We're on a roll, bro. Okay. In the qualitative cation analysis procedure, BI3 plus is detected by the appearance of a white precipitate of bismutyl hydroxide. Calculate the pH of a saturated aqueous solution of BiOH. Okay, so I'll just rewrite this equation. Probably just gonna have to use the ice table because we want to find pH. So what we could do is just find the concentration of hydroxide ions. We don't even need this. Find the pH, and we know the KSP. Okay, that's light work then. KSP is equal to x squared is equal to 4.0 times 10 to the negative 10. X is equal, bro, I didn't even need to write out that still. That was low-key pointless. Okay, so this is 2.0 times 10 to the 1, 2, 3, 4, 5. Negative 5 moles. So then this is hydroxide concentration. Boom, POH is equal to negative log of that. 4.699. So pH is going to be equal to 14 minus this. 9.30. Boom, that's our answer. Boom. Let's go, bro. We're cooking, bro. Next question. This is low key light, bro. And just watch me like get cooked on the midterm, bro. Come on, yeah, there's like something lingering in the pause, but it's like something like stuck. Not stuck, it's just there. It's really annoying me right now. For which salt in the following groups will the solution depend on pH? Okay, let's think here. So pH, that's like H plus H3O concentration. Well, why did I write it like that? H3O. So the way the solution will change. Okay, the way the solubility will be affected is based on the initial concentration of H plus. So out of AgCl. Okay, I have a hypothesis. Actually, no, I don't anymore. Okay, because there's. So I brought no clean close. So HCl and HBr are strong acids. So that means what? Okay, so I have a. Okay, I believe. Okay, because these two are strong, right? Because it's HCl and HBr. But I don't really understand the reasoning, so I know the answer is AgF. Let me just read the answer key, what it says. HCl, HBr strong acids. Okay, that's right. Dissociate completely with H plus and Cl minus, or Br minus. Okay, what? Okay, so it's saying H plus. I don't understand that part. Why did I even write that? I don't even understand it. AgF. Okay, let me just write out this reaction mechanism. So what does that do? So what's saying is that the hydrogens will react with AgCl and AgBr. So, okay, I would understand if it's saying if it will not depend, but I'm looking getting the reverse answer right now. Salts have ions. Increased solubility will occur when the product A minus is removed. Okay. Salts that have anions of weak acids will be influenced by pH as the anion is being removed. Okay. So what it's saying is, okay, so Cl and Br. Wait, no, I don't get it anymore. Produce salts that have anions. Okay, so HF is weak, right? Okay, I really don't get this fully yet. HF, weak acid. So so F minus will react with H plus to make HF. And when the F minus reacts, the concentration of F minus will decrease. And if we decrease the concentration of F minus, the reaction will progress to the right, and that'll increase solubility. So therefore, AgF will be affected by solubility. So I'm not fully understanding of that, but yeah. Okay, so for question B, what would it be? PbOH or PbCl2? Okay, so I think this is pretty easy. I think it'll be PbOH2, because just by writing it out, right? We could see that if we have a higher pH, we'll have a different concentration of OH, so it'll have to be PbOH2. and PbCl2, okay, SrNO3 2 SrNO3 2 SrNO2 2. Okay, wait, what's the strong acid out of those two? So I HNO3, right? That just sounds right. Okay, so because HNO3 is strong, I'm assuming that'll just be SrNO2. Yeah, that's the answer. So I think it's just the one that's not the strong. It's just the weak acid or weak base will interact with the solution and change concentrations. Yeah, that makes sense actually now. Yeah, okay. That was a bit odd. Okay, question 5. But my voice is fading, bro. Okay, question 5. PbCl2 precipitate when 155 mils of 0.0016 moles KCl is added to 245 mils of. Okay, so would it precipitate? Okay, so the ion. Okay, I think what we're gonna have to do is find the formula sheet, wherever it is on my thing. Okay, I have it right here. Okay, so the ion or the salt of interest. Okay, so let me just break this down. Pb2 plus Cl minus, and then we have Pb2 plus NO. Wait, why am I writing the same thing again? Is added. Would PbCl2 precipitate? Okay, so this. Oh wait, what? I'm not even writing it right. Okay, so we already know what salt it would be. Okay, so. Okay, wait, my bad. Cl2 KSP is equal to. Bro, I have to finish my English as I just remembered. PbCl2. Where is it? 1.2 times 10 to the negative 5. 1.2 times 10 to the negative 5. Okay, step 1 done. Now what? Let me just move this tab. Okay. Okay, so we know the KSP. What do we even need to do then? Would it precipitate? I think we just need to find out. Okay, I think. Okay, let me just draw this out. Maybe this is a bit too much work. Okay, so 155 plus 245. I just want to make sure I understand this fully. Otherwise, there's no point in me doing it. 0.4 liters. So we're tossing in KCl, PbNO3 mink. Okay, so we're tossing those in, and we're trying to see if soluble form. So we know that once the reaction proceeds this much, then we'll get a solid or a precipitate or whatever you want to call it. So we need to find out what the current state of the reaction is at in order to find out if a precipitate will form. So we're going to find QSP. Okay, this is starting to make sense. Okay, how do you find QSP though? That's the question. I see. Okay, PbCl2. I'm low-key like making connections right now. Pb2 plus 2Cl minus. Okay, excess. Excess. Why is my Apple pencil? Why did I say? Why is my pen not working? Okay, 0 0. Wait, no. We're just trying to find the initial. We're not even trying to change that. Okay, we just gotta find out what the initial molar. Like what is the moles per liter of each thing? Yeah. Okay. I think I'm doing too much right now. But we need to make sure that we do it over the total volume, because then it will be different. Okay, so let me just cook up right now. I'm not even cooking up. KCl 0.155 liters multiplied by 0.016 moles per liter. Cancel. This is equal to 0.0024 divided by 0.4 liters. 0.006 moles per liter. Okay, boom, that's done. Now NO3 but keep in mind, we're just looking for, okay, do you see how the NO3 has 2 though? I think we'd have to do some weird shenanigans for that. Like you have to multiply by 2 or divide by 2 or something like that. I can need to like study that. Let me put that in my notes. Would okay, but my bad. Okay, so now we got 0.245 liters multiplied by 0.175 moles per liter multiplied by 1 over 0.4 liters. Let's do it all in one step. Yo, I actually don't know where my voice is going, bro. Just decided to leave. .107 moles per liter. Okay, nice. Now what? Roller. Can my pen write? Is my thing dead? I don't even know. Okay, wait. Okay, so we know that that's that. Okay, so QSP is going to be equal to, remember the 2 here, so we have to square it. 0.006. I'm assuming we don't put units there. Why would we? What the heck? Okay, 3.86. 1, 2, 3, 4, 5, 6. Okay, 6. Now compare it. This is smaller. Okay, QSP is less than KSP. What does that mean? We need more products. Proceed to the right. So what does that mean? No precipitate. No PPT. Because keep in mind, like think about it, if we're proceeding to the right, then we're going to be we're going to form these ions. If we were proceeding to the left, then we would form the solid, but we're not. So that's the point. Okay, nice. Okay, how many more questions? 6, 7. Okay, almost done. You did not hear me say that. Ain't no time that I'm not inside. I don't realize that I should be inside with you. Low-key, I'm going to keep these 2 for posting it tomorrow because I'm not going to be able to record a video tomorrow. So I'm just going to end this recording here, upload the previous 4 questions, and then these 2 questions will be uploaded for tomorrow. So, yeah, my bad, but it'll just be optimal for me. Because I want to post every single day, and I genuinely will not have time to study because tomorrow my thing is at 6 p.m. So, yeah, see you tomorrow. Goodbye.